Okay. Good morning, all. Can you hear me loud and clear?
Yes.
Okay. Thanks a lot for giving me this opportunity to present myself about this technology, to give the introduction about the technology and how good the future is going to be with this new technology. And I made a few slides for today's session also. And I'll try to share with you guys in sooner. And I'll be joining with my technical assistant also, Mr. Ganesh and Teddy. And if you have any questions or anything, please put me a message and I'll try to answer at the end of the session. So for today's, it will be a basic introduction of the virtual and augmented reality and how to install the software requirement for developing this technology, basically. Yeah. So if I
you can
yes,
share the presentation.
yeah, I'll try to share the presentation. So is it okay now? Should I start or should I wait?
Admit.
Can you see my screen?
Yes, sir. Yes.
Okay.
Now you can see, probably you can maximize it. Okay, thank you.
Is it clear now?
Yes, sir, you can go ahead.
Okay. Thanks a lot. So very short introduction about me. So I'm Anil Kumar Ala. I'm head of the training at Excellence organization, and I'm also a lead developer in augmented and virtual reality. And this is what we are going to cover today's session. So I'll start with a basic question. How many of you are experienced the virtual reality or at least augmented reality? Okay.
I think the participants can make use of at least chat box or they can switch on.
Yeah, at least they can send me a message or something like that. That will be useful. Yeah. So it looks like. Yeah. Very fine. So at least a couple of them I have experienced the VR. So not a problem. By end of this session, end of the lecture, we'll try to develop a few applications, and we can directly buy like a Google Cardboard, which is very less than 300 or 400 rupees, which costs you, and you can experience yourself your own application. Okay, so let's jump into the sessions for today. So what is virtual reality? What is augmented reality? What this technology is about? Why do we need this technology? So let's start. So what is virtual reality? In general, virtual reality is nothing but it's a computer generated simulation of a 3D environment. Which seems to be very real to the person experiencing it using a special electronic equipment. We call these equipments as a HMDs, basically. Nothing but head-mounted display, which we keep towards our head. So if you look at today's consumer technology of VR, it evolved like there are so many head-mounted displays available in the market to view the stereoscopic 3D scenes, basically. So what you can do with this, with these headsets? So basically, with these headsets, you can look, you can move your head up and down, left and right, all this stuff. You can view the 360-degree, and you can walk around in this in a particular in a particular design area, in the particular area. Uh, and using the hand controls or motion sensors, you can just walk like a normal, how you walk in your normal daily life. You can walk in the real time, sorry, in the virtual time environment, basically. So I'll also try to try to. It's better to share the slides also, maybe. Then I can. Just a moment. I have a few videos also, like who didn't experience. So I'm just sharing the slides also, so you'll have a better understanding. So I just posted my slides in the chat box. So here Nikhil is trying to show one HMD here. We call this as an Oculus Go, basically. So this is like where we call this as a mobile VR, basically. So you can take anywhere you like. There you don't need any wires or anything. But the only thing is, like, you can only just stereotypical 3D 3D images or 3D videos or 3D movies, or in future if you're having a 3D websites which are going to be soon. So all these things we can do it here itself. So my slides are accessible to everyone. Yeah, okay, good. Thanks. Okay, so most of the people think VR is only for games or for any kind of a 3D applications or any kind of a simulators they think. But in today's and present life, it has more than the gaming actually. So any business which deals with 3D modeling or a computer graphics or any kind of all this stuff, CGIs, so they can use this technology. VR is very helpful in this in this field, like to immerse themselves in the world, and they can do all kind of they can see, they can change the colors, or they can change the dimensions, or they can change the things in the real time, so that which we don't need to relate once after it's done. So you can do all the things in online itself, then and there itself. Not only this, in future, like there are already some applications which are into the engineering, social networking side, shopping, marketing, entertainment, all this stuff. So especially, so here is a video of the particular VR, what exactly you can do. This guy is trying to play a game, basically. So yeah. So these are like different HMDs. So the one which Nikhil has shown you is the first one, and the second one is a little bit more highly immersed HMD, we call this. So there are two types of HMDs basically. One we call as a desktop VR, another one we call as a mobile VR. So what's the difference between these two? So in desktop VR, basically what we can do is you have wires attached to the computer, and all these wires are attached to the HMDs also, and you have two controllers and a sensor or a camera In some HMDs you have a camera, in some HMDs you have a sensors basically. It depends. And some you have a magnetic fields also. So they're quite wide range of HMDs. But the end of the day, the functionality wise, it's almost same. These HMDs only the tracking, the way how they're tracking the position is only a difference. Otherwise, the rest almost everything is same for almost all the HMDs. So here in the desktop VR, so basically, if you want to play if you want to process a heavy graphics, we use this desktop VR basically. So this can be a Windows machine or a Linux machine or a Mac machine. It's up to you. So Oculus Rift, HTC Vive, or these two other companies which have this desktop version of the HMDs, and these have a generally high graphics power unit, basically because the computer itself, the laptop or a computer which process this graphics, which process this graphics. That's the reason we call this as a desktop VR. So there is another one is the mobile VR. We also call this full immersive VR or a 6DOF VR. So nothing but a 6 degrees of freedom. Basically, you can rotate, you can move all the directions. That's why we call this a 6 degrees of freedom, basically. So another one is a mobile VR. So the best example is Oculus Go, Cardboard, and so many. There are so many wide varieties of HMDs available in the market, which ranges from 300 to up to 20,000 also. Generally, the full HMDs, the full desktop VRs and all will cost you around 30,000 the starting price, and it goes up to 80,000 to 90,000 also in today's market. So coming back to the mobile VR, so mobile VR starts. A good example is that Google Cardboard, which is available in the market. If you go to a Flipkart or Amazon, you can get it. It costs around 300, 350 rupees or something. So here in the mobile cardboard, in the cardboard or any mobile headset, your phone actually works as a computer basically. It depends on your phone how fast or how speed or how quick the resolution, or it depends on the resolution, or it depends on the field of view, on the focal length, all this stuff. It depends on your phone. That's where the experience of the HMDs will be. So what exactly you have in these HMDs basically? So all HMDs have two lenses. Especially in the mobile, you have a slot where you can keep your mobile phone inside that. So your phone itself will display. Your phone displays will be used to show your twin stereoscopic views basically. So you have two views basically, one for each eye. Sorry. So it has both rotational head tracking, and it doesn't have a positional tracking. It has only like head tracking. Based on your head tracking, it will give you that stereoscopic image basically. So how does this work basically? So in each of all these devices, we have this chip called IMU, inertial measurement unit basically. So this helps for the HMDs to show which side of the image you need to display basically. Here in VR, in this VR headset, it doesn't display the full image. It displays the image where your eye exactly looks, or where exactly that stereoscopic image you're looking for. Sorry. So not only this, you have actionability like tab or cursor or press button. this kind of a stuff where you can interact with the user interface basically. So Google Daydream, Samsung Gear VR, all these are different headsets, and for the mobile VR, and we call this as a 3 degrees of freedom because of only the rotation we have, only the head rotation we have. Most of the nowadays these headsets HMDs which are coming, which doesn't also require a phone also. It's the same kind of a features except calling. Almost all the features are coming inside the HMD itself. So the best example is Oculus Go. So the next topic is about the augmented reality. So what exactly is the augmented reality? It's basically, we call it as a sister technology, or the technology which almost relates to the VR. So what is this? So augmented reality technology is nothing but a technology which combines a computer generated imagery with views of the real world. So basically what will happen is, so any kind of a graphic content or a digital content which displays or which augments on top of your on top of your, or like which relates, maybe I can put in this better way, any digital contents which overlay on top of your real world, that's called augmented reality in a simple term basically. So we call this as a superimposed. So even though it looks like it's blended with the real world, but it really is not like that. It's only it only works. It just overlays that graphic content on top of yours via smartphones or tablets, or it can be HMDs, or some AR glasses. AR glasses is the one which they're going to be in the market soon, maybe in the September. Apple is going to come and Google is going to come. So AR glasses similarly looks like the one like a Google Glass, which are like maybe 5 or 7 years back, the Google has released these glasses. So these glasses looks like an ordinary specs, and which has a camera inside it. And there is some processing power inside these specs basically. So you can say the most processing headset which is available in the market right now is the HoloLens and the Magic Leap. The HoloLens, which costs around 4.5 to 5 lakhs. Magic Leaps also almost cost the same thing. Okay. So where exactly these technologies they use in the market in today's world? So mostly they use in the travel and tourism industry. So suppose you want to visit Delhi or New York or London. So all you need to do is take a 3D camera and try to shoot and put it in the, it can be a browser, or it can be a video, or it can be image. Just put this and integrate with your VR. And you just feel like exactly you are in that location and you're exactly seeing this location. And not only this, you can use it in the travel, mechanical engineering, and industrial designs also. So generally a CAD file, or such as like AutoCAD or SolidWorks, or any 3-dimensional modeling or simulation or visualization. With the help of this technology, VR, the engineers and design can directly experience that end product before it actually built and play with what if in the scenarios are like very at very low cost or very high cost, what will happen, the automobile designs, or all this kind of stuff. Sorry. Okay. So the next one is the architecture, and in the civil engineering, most of these architects now use the constructed scale models for the designs. So to pitch their clients or the investors, most importantly to validate many assumptions about the designs basically. They use this all kind of rendering softwares to build these virtual models and their architecture plans. But with VR, it's just a headset you need to take. That's it. The same you can display to the, not only display, you can even collaborate with the different teams of the engineering or the architects in the company or around other organizations also. So real estate is the one important industry where they're currently using the VR, especially in this COVID situation. So all these real estate agents, mostly they quickly adapted the VR technology to sell the flats. They just scan or just do the scanning part in, they just scan the flat, or they, if they already have a 3D model of the flat, they just try to quickly implement in the VR, and they just send a link or a headset along with their agent, and that's how like they can visualize the flat, and they can see how exactly and which floor what will be the view on the left side, right side. All this they can see instead of coming to the physical location. And next one, in medical field, this is a potential big market which we are right now they used, especially for the training of the doctors or nurses. They're using right now. So every day in hospitals they use MRI and other scanning devices to produce these models of our bones and organs that are used for diagnosis basically, to possibly say, hey, this is what happened with your body organ and all. So with VR, what happens is you can visualize and measurement also. You can use this in a 3D way. So not only in the length and the breadth, and you can see the depth of the wound or the depth of how the fracture it is. So and even for the training of the simulation or for the surgery of the medical students, all these things they can use it. And one more, this scientifically they are trying to use, especially in a post-traumatic stress order. We call this as a PTSD or exposure therapy. Especially patients are treated with this kind of, especially if you have, anyone having this fear of spiders or fear of flying, all this stuff. They put this VR headset, and inside that they have this all the simulations. They just project it to the patient. The next one more big industry they are trying to use right now is the education field. It's the same thing like with the doctors, how they use it. They're using in the education sector because of the, especially in the COVID situation and all. They're not schools and no colleges. All they need to do is the same syllabus can be simulated in the VR. And it is like it will be more interacting. It can be more interacting. Suppose if a student want to see a solar space, all he need to do is just click on the solar space, and he can visualize that solar system, all the solar system, and we can visualize all the difference of between and how big all these planets and all. He can visualize very naturally and interactive also. And the next industry you can say is this automobile industry. The automobile is a huge industry where they're trying to train their engineers or the drivers, especially or the teenagers who wants to drive, how to drive a car and all. They're using this technology to help these people basically. And not only this, in the emergency cases like for fire or fire and rescue department or for police, so how to train like in situations where in a physically it's very highly high cost rates to train people in a natural world. So in VR, it's very cheap and very easy to use also. And in entertainment industry, it can be done by using 360 degree movies, or like a 3D movies, you can say. And not only that, if some nowadays, even the last couple of years back, this IPL, which they used it a 360 degree 360 degree entertainment, basically. 360 degree cinematic entertainment experiences, you can say. So where you can literally see where exactly how the player walk from into the ground, and how he plays the shot. You're like seeing very close to him, even though you're far away, but you can just see that visualization very near to him, very near to you. So these are the different industries where VR is used in nowadays industry. Not only this. Earlier, it was only meant in a particular industry, especially in military and all. They were using from like almost like 3 to 4 decades that you were using this technology. Those days, it was very expensive because of the mobile computing process. It has become very cheap, and that's how the commercial applications and commercial designing, all these aspects came into existence. So how does now I'll try to explain how this technology works, basically. How does it work? So basically, these are two basic areas. Basically, one is a 3D viewing and one is a head pose tracking, basically. So 3D viewing is where exactly you are looking at, what exactly a 3D model, which you have a 3D model or 3D graphic content, and another one is a head. So whenever you're trying to rotate your left, so it's sending the sending the data to the sensor, or to the processing, to the computer, saying that you turn to the left, so that it only now shows only the left side of that particular image. So I told you, like, because of this IMU, this is where exactly will tell you where which side you are rotated, which degrees the head is rotated. Based on that, your position of the head at that particular time, it can calculate and give you that particular scene, basically, and it can immediately render that graphic to that particular viewpoint, or we call this generally stereoscopic 3D viewing. So one more important factor, especially with this technology, is the field of view. So generally, the field of view for any television sets or any normal entertainment stuff in our home is generally 30 degrees or so. But in VR, it should be greater than 100 degrees. Most of these cardboards are like 90, 95, all the stuff. But Oculus Rift and all these are 100 degrees of field of view. So according to this Oculus scientist, Mr. Michael, so what exactly meant for him to the VR is, so our normal eye, which looks at a particular image, it has a resolution of 16,000 by 16,000 pixels. That's the normal resolutions of our eye, which we look at. But for today's technology, if you look at Oculus, the high-end HMDs or high-end graphing cards, we have only the 4K resolutions. So still, the technology needs to be improved, and there's so much research involved in this. So one more thing I want to bring to the notice is while developing these HMDs, they keep all these things in mind by the resolution of the display, the field of view, the focal length, and the cost. So these are all really matters to be a good HMD or a good headset. And one more thing, one more important thing which really matters most is the motion sickness. So motion sickness is a most challenging part in the VR. So whenever we develop these applications, this motion sickness is quite common. So if you suppose we have a high rich content of a graphics, which takes so much time to render with a normal mobile processor. So if you put this VR headset in that, if you put this VR headset and you try to visualize, you feel like a headache or dizzy or some kind of your eyes start getting pain or something like that. Because if your application rate, we call this as frames per second, we call this as FPS basically. If this FPS is less than 60, you feel like this. So mostly your application should be minimum 60 frames per second to make sure your that motion sickness won't be there. So why this motion sickness will be there? It's because of our natural impact or natural enmity between the organs basically. So your eyes are seeing and your body is doing something. So it's not matching basically. So in our daily life, if we are trying to walk, what we do, we see and we try to walk like a normal. But here, whenever we are covering with a VR environment, even though we are not walking with our controllers, we can make ourselves walk. So that's how this sickness will start. This motion sickness or this kind of a sickness will start. Kind of a challenge in this industry. So we overcome mostly by making our application as smooth or as high the frames per second. This by this way we challenge all these challenges basically, you can say. This frames per second, all this stuff. So not only this, and even we can implement these 3D sounds in this application sounds also. So this gives you like we are watching in some some theater or that theater kind of experience. You can get it. So we have here like a couple of different types of VR experiences we have. So we call a diorama. So this is a kind of a simplest case where you want to build a 3D person. You are looking from some particular angle. So if you're playing games, you're looking from a far distance. How these two guys are like this environment is playing like that. So we call this as a diorama basically. It's a simple you're just watching in the stadium how these guys are playing. That's it. The thing is here you can You can just view this stereographic view like just by rotating your head, all this stuff. So the next one we could call is this first-person experience. Basically, this is like you inside the environment. So you yourself, we call it as a player, basically. So when you are in the game, you are the player. So in your perspective view, in your view, you are playing the game. So this is like a normal, in a normal view, in a normal personal view, how it exactly when we play. So when we rotate, we move left and right. We are not in the stands. We are in the ground, basically. I can say we are in the grounds and we are playing the game. This is like a first-person experience. So another one we call as an interactive virtual environment. So this is like these are like mixed of the first person can experience and the diorama, basically. So so here you have a advantage is, so you can interact with the objects, basically. So you can interact with the objects like a graphic content. It can be a 3D model, it can be digital content. So when you're when you're trying to play cricket, you hit the ball, you can catch the ball with the controls, help of the controllers. It can respond to you. You can throw the ball. It gives you how fast the ball is moving, at what speed. All these game mechanics and all, you can do it here. Another one we say is 3D content creation, basically. So any artist who wants to draw the pictures, they can do it here itself. So with the help of the controllers, they can tilt the brush, they can use different brushes, and they can have this artistic view, design all this stuff. Maybe the best examples are, and the best examples available are Google Blocks and Oculus Media, all this stuff. And another one is like 360-degree media. We call this as generally GoPro cameras. These are the cameras which take these panoramic images and all the stuff. So if you want to view those images, so VR is this is another type, basically. So it can be a video, it can be an image, it can be any, it can be anything, basically. These two can be. Basically, you're projecting a video or an image which can be rendered with the effective, with the effective sense, something like that. So the next one is a social VR. Social VR is generally like the same thing, like how we have a Facebook, Twitter, all these things we have here. When we where we can interact with multiple people. So VR space is like that, basically. So here what happens is, here you have avatars, basically. Avatars which will tell you, which will give you a particular form, and you can interact and you can speak and you can do all these activities. So next thing what I want to talk to you about is the technical skills that are important for the VR to develop these kind of VR applications or AR applications. So first thing is, we call this as a world scale. So when I try to install this software, I'll try to explain more about this world scale also, but I'll just give a little introduction of this. Basically, world scale is, so whenever we want to develop any VR experience, we need to keep in mind about this 3D space and the scale. 3D space, nothing but the position of an object in this 3D environment, in the vast empty space, where exactly the object is, or how big it is. That's what important. And the next one is like controllers basically. So it can be your camera or it can be a gaze. Gaze is nothing but like a dot. I'll try to show you when we are just trying to develop an application. Or hand input controllers and the head movements. And the next one is the user interface controllers. So similarly, like how we have a user interface for our mobiles, so we have the same thing for our for the VR also. So same here also, we have buttons, we have radio buttons, we have a drop down navigations, all this stuff we have selectors also. But there's a challenging part in this user interface is we need to create this user interface in a 360-degree view. It's not like on a flat screen or on a flat mobile. We are not developing it. It's like a kind of it can be a curved, it can be something like a tilted, something like that. This is about the user interface controls. And the next one is the most important technical skills which we challenge to prove exactly how we do it in the natural world and how we do it in the physical world. That's we call as a physics. So physics control is nothing but physics, nothing but a gravity. So basically in the gravity, what we do, we move, we throw the ball. When we throw the ball comes down. All this natural activity which we do, we can do it similarly in the VR environment also. We call this as a physics and gravity. So the next one is the animations. Animations, basically, if you want to animate any particular graphic content, we can do the animations. We can use these animations for our logical purpose or any kind of interactive purpose or anything like that. And these are all like multi-user services. So not only like it's not like a single player applications, it can be multi-user. That's also. So if you want to collaborate, if a person want to collaborate far away distance, like a person is sitting somewhere in Delhi and somewhere we are in Hyderabad, and we want to develop this collaboration, we can still do it in VR, where our 3D model will be placed somewhere in the server, and both of you are interacting with each other at the same time. And one more important thing, especially in the VR AR industry, is so unlike the native applications, here with using the Unity software, where we can build and run and optimize all these different platforms. So build one application and we can run these applications on different platforms like Android, iOS, all this stuff. So instead of, even though we don't need any Android Studio or X project or Xcode. So with the help of Unity, Unity helps all in this. Unity helps on all like solving all this, helping us all this in just creating these applications and all. And not only this, and if you want to design a particular environment like a terrain or something, Unity helps. Unity already have all these features basically. So before going into the Unity or AR, I can say. So I want to stop for like a minute, and I want to take your questions if you have anything for so far. Do you have any questions for me? So at least 60 frames per second we should consider for VR. So less than 60 seconds, you feel headache if you put the headset. You don't feel like putting it at all. So, oh, sorry. Yeah, exactly. So this computer generated image is nothing like, basically it's a digital content. So this is like kind of a cheating the normal user. So so how exactly it will look like, even though the digital content is on top of your mobile screen, but it feels like exactly it's in the normal screen and it's in the normal physical world. You feel like it. So that's why we call this as an augmented reality. That means nothing but superimposed. That's kind of like you're overlaying the digital content in the natural world. I'll try to show when we are into the real time development how this works and all this stuff. How do we all this stuff? But it's kind of like cheating the normal person. All these mobile VRs are wireless, and only Oculus Rift and HTC Vive are the desktop versions which are wired. So if you have a real high-end applications which needs a high computer generated graphics content, then you need to use the desktop version, or else your mobile works pretty much. It depends on the requirement, basically, you can say this. So suppose if you want to also track the position of the person, then you need to have the desktop HMDs, basically. Of course, if that's what we need GPUs, especially for the desktop version. Why we are going is because of the GPUs, basically, because of the high rendering stuff. Because VR is completely virtual world, so you are creating your own particular world. So there's no natural world here. So we need to develop all this environment in a 360-degree. Especially for VR, we need. Yeah.
Nikhil sir, you have to unmute. Nikhil sir.
No, maybe Nikhil is talking to someone else, maybe.
Okay.
Yeah, HoloLens is available, but it's only for the commercial use, not for the normal user. Earlier it was earlier they were doing they are giving it, but now only for the commercial, but only for the enterprises there. No. Why we have this white? You can go to this Oculus page for Oculus website, HMDs. These are the different HMDs available, especially if you want to have a high-end application. If you want to have like environment, tourism, all this, entertainment, all this than ordinary Samsung. There are so many HMDs which are available. So this is where you can get your HMDs, and the price also is displayed. And earlier, it was very tough to get these hardware now, but nowadays it's very easy and pretty easy to get these hardware. Most of they have the shipments to India. This is a very good question. So, this is still in research phase, but mostly they say less than 13 years old, they shouldn't use this HMDs, especially that may affect their eyes. So still, the scientists only said that less than 13 should not use for the time being. So these are like challenges in this industry, because these are still in research modes. So not exactly sure how far even the older generation they can see or not. That I don't know the age limit, but less than 13, I'm pretty sure not to use it. Obviously, the younger generations and all can use it, but I don't know about the older generation. They can use it. I saw the videos, people who are the grandfather, grandmothers and all using and playing, playing in the VR. But I'm not sure about what the side effects or the technique, these things will affect their eyes. So any questions more? Any more questions? Okay. So earlier, like Nikhil showed you one HMD, that is Oculus Go. So right now I don't have this HMD, but in the next session, in the next coming classes, I'll try to show you the difference between the wired one and the wire, how big it is. But all these images are there in the presentation also. So Mr. Vijay, so approximate cost of the HMDs. So it varies basically. It depends. So the cardboard costs you 300 to 400 maybe max, and if you take this wide, it will cost you up to 80,000, 90,000 also. That's a desktop based one. So it's all like basically it depends on the requirement of the application. For most of these mobile VRs, these are less expensive because your phone acts as a computer. Here, in the desktop one, these are a little bit expensive. Start from 25,000 to 30,000.
Anil sir, 1 minute please.
Yeah.
Participants are requested to post the attendance through the link which is posted in the chat box. Once again, the participants are informed to post the attendance through the link which is posted in the chat box. For every session, the attendance will be taken like this. The link will be posted during the session. At any time, we will post the link in the chat box. You are requested to post the attendance timely. Thank you.
Yeah. Apurva, yeah. You can go ahead with the question. So almost all these big companies are working on the VR. They already have this special because now the VR. There are most of this automobile industry. If you go to our nearest any auto dealer, they have this HMDs available in their showrooms also. If you want to experience, see most of these why they are using VR is they can't put all their they just put only one car in the showroom or two cars of their models in the showroom, but they can't put multiple models and multiple colors of this. So now they are using it in almost in all the auto showrooms. They have this. Even Google also have this VR. Google Google have almost all the big companies. Even share can link. Okay. If you take an Indian companies, Deloitte, Infosys, Tech Mahindra, Wipro, all these have this VR development basically. Yeah, even TCS also they have this branch in. Yeah, the Reliance has a Reliance Reliance Jio is coming with their own headset, which costs around like 1,500. They're working on it. Yeah, basically, yeah, they use this AR, the frames we call it as basically. It just overlays. If you take this snapshot, you have all these funny kind of features and all. So these are all like best example for that, for AR. No lens cut, no, not VR, but this is. This is not exactly VR. Basically, what they're trying to do is they are trying to put the dimensions of the of our this thing, the head. Basically, what they say is left how much, right how much. Based on that, they are trying to create that simulated image. So on top of that, they're trying to change that because that's not VR. Basically, the VR should be completely filled with a virtual world. So you can't see the real world basically. Snapchat is a good example, and maybe you heard this Pokemon Go game. That's also very good example for the AR. So generally, the game is about there will be so many Pokemon, so you need to walk and you need to catch those Pokemons. Then you won the game like that. Even Mario kind of games where you play on your laptop or on your phone. Now you can play it on your real-time environment. That's in your natural world, and even though it's not physically there, but you feel like exactly there's something there. The graphics is just overlaid all that. So only the difference between VR and AR is that VR is completely closed environment. You don't have any physical environment here. Here, whatever you're generated is a computer simulation generated environment basically. In AR and all, it's like your physical environment, but the graphics is overlaid or like superimposed, we call it, on top of the natural world. So how basically it works is like you put your camera. So camera, whatever you can see through the camera, on top of this, on the screen, the graphic content is overlaid basically. So only difference between these two is one is a completely computer generated environment. Other one is a artificial. Other one is a physically environment, physically present environment with overlay of the computer graphics, basically. Yeah, there are separate HMDs for AR and VR. So I was this HoloLens is for AR, Google glasses, all these are for AR glasses, all these are for AR, and VR is for like Oculus, HTC Vive, all these are for VR. So for AR glasses and all, like still not fully commercialized, but only except Microsoft HoloLens, and the other are all research phase or not yet available for the public, basically. For AR, no, not right now. Maybe this thing you can afford. Just figuring out. Maybe this Google Glass you can afford, but they're not in the production anymore. Earlier it was there, but not anymore. This is like a HoloLens. This is how big is. This is like quite heavy also. They're coming with lighter versions of the AR headset, basically. Apple is also coming with the same kind of a glass. How say this kind of a structure, this kind of like a Google Glass they're coming with. So you mean the Nagarjun sir? You mean the link for the slides? AR model. So AR model is like, again it comes to a 3D modeling. It's the same as a 3D modeling. Any company who does this 3D modeling, there is no specific AR model. It's just a 3D modeling company. 3D modeling tools, same thing like Sketchfab or Autodesk tools, all this same thing. But we use a low poly end. We call this as a low poly end. Low poly end, or like not highly generated mesh, we call. So mesh is nothing but these are like triangles, like how you generate your 3D model. It depends basically. So we use a low generated 3D model because to avoid high rendering stuff, more calculations basically, you can say. If you're going for a high end mesh and all, then you need to go for high end VR HMDs. Or else your phone, if you're using on a phone, then your phone will it'll get heated in in the 5 minutes, and you can't use that. You can't use that. Maybe your phone gets stuck or something like that because it doesn't have enough processing power. So this is even the designing part is also another challenge in the VR and this industry. Because it should get all these animations, it should get all these materials, all the colors. I think we call it as materials, but generally it's the colors and how many meshes, all this stuff. So it's always better not to go for the high one, go for the low one. And depends on your requirement also. Okay, for this, at least in the lab, at least you should have at least one or two, maybe a desktop VR headsets, and you can get this mobile VRs and all. You can get as many as one because these are less expensive. Maybe at 10 or 15 we will do, as these are a bit expensive, and you need not all the laptops also supports, only dedicated graphic cards only supports these HMDs. So that's the reason. So you need to go based on the specifications. So not only the HMDs, you need to go up to the laptops also, laptops or desktops. So basically you need a 1080p 1050 should be 1080 graphic shot should be fine. So if you're going for the Oculus, then it should be 1080. More than that, basically. It's more than that. So our company is working on, basically we are developing on AR application, which this application is like an ERP side basically. So what we do is, see, any person wants to have their own AR application. That is the platform which we are creating basically, where any normal user can upload their graphic content, and he don't need to build again and again or different applications. You don't need to go for a developer or something to build their AR application. Our product will create that. All he needs to do is put the content, we'll give the link or we'll give the application basically. This is like from a small this ranges the product from small sweet shop or like a small shop owner to a big company also. They can use this product. No, not may not exactly to the Unity Advertiser app. Unity Advertiser, this is like a business model. Maybe the same business model, but not really exactly like what Unity does. Unity only generates few advertisement app, but not ours is not like purely based on advertisement. Ours is also like a subscription based model also. And this is purely basic business model, but ours is not like that particular to a specific area. We are catering from a small shop to a big enterprise also. So one application for all. So that's how the complex core is about. Here is the complexities about. Yeah. Yeah. And before going to the next session after 3 o'clock, so this is a software which needs to be installed on your computers. So if you don't have your computer at right now, maybe try to get a computer at 3 o'clock. And at least it should be a 64-bit machine. It doesn't support a 32-bit machine. At least make sure you have a 4 GB of minimum RAM. If it's greater than, it's better. So if anyone using a Linux machine, they're also fine. You can put me a message so that I can give you the link. Anyone using Mac also, it's fine. For Windows, it's fine. Anything is fine. For Windows, it's fine. But make sure it's greater than 7. 7 works, but better to have a greater than 7. And if possible, try to have a webcam not for VR application, but for AR application, we need a webcam, or any laptop with a webcam is also fine. Yeah, that will be developing the application, how we can change the floor background and all. So so I'll tell you how exactly we does that. So we change these materials of the floor, not the real floor, but it's the graphical, the 3D model of the floor. Or any other questions? And by the way, I want to tell you about the history of this HMDs also. These are not new actually. They are there from 1967, but because of the hardware limitations and software limitations and the availability and the costs, now because of the latest mobile computing, these has become cheaper. So that's how the commercially viability has come. That's how people started showing interest in this field. Earlier, the most of these HMDs were only for military or any kind of a particular simulations. So I hope I answered all your questions. So if you have anything, just put me a message. I'll try to help you. Or else over to Chanariki sir.
Thank you, sir.
Yeah. So at 3 o'clock, we'll try to install the software. I'll share at 3 o'clock, at the 3 o'clock session, I'll send you the links for the software to download, and I'll tell how to install the software, all this stuff.
Okay, sir. Okay. Okay, sir.
Yeah.
Again, sir?
Yeah. Yes, sir.
Shall we meet again by 2:30 p.m., sir?
Sure, sir. No problem.
Yeah, sir. Okay. All the participants are requested to join for second session on day 1 at 2:30 p.m. Session will start at 2:30 p.m. Please join early. Now, with the permission of resource persons and Professor Channareddy, sir, I am winding up the session. Sir, shall I close, sir?
Yes, sir. Sorry.
Yeah, all the participants can join through the same link. The link which is this is the link for all the day. You can join the session by the same link. Please join the session by 2:30 p.m. Okay.